Okay, is everyone ready? Great. Today, we're going to embark on a new adventure, core civil cells. What are they? You may have heard of civil cells. Well, core civil cells are even better. My name is Mike Barcassi. I'm an application engineer with Bentley Systems. Been working with civil at Bentley for nearly 9 years now. This is the first in a series on core civil cells. So join me and we're going to work through these things together and get everyone out there following this up to speed, up to date, and empowered. Civil cells, new technology released in Select Series 3. You can think of them as reusable design. In this presentation, the first of many to come, we're going to deal with their uses, understanding them, their challenges, and most of all, we're going to introduce you to the exciting new core cells that we're providing in SS4. Before we start, you need to know what Open Roads is. I'm sure you've heard of it. If you're watching this, you've probably been working in it for a time now. It is information modeling functionality. It's a common tool set that's found in Inroads, Geopack, and MX, and all their other products based on that technology. It's the same, essentially the same set of tools across 3 platforms. Those tools provide realistic modeling, real-time visualization, information mobility, and intelligent parametric-driven design. Nowhere is this seen more completely in one place or one tool set than in civil cells. What are civil cell, or what is a civil cell? It's a reusable instance of a portion of a design containing both 2D and 3D elements, terrains, and components. All rules, dependency are moved forward to the design where the cell is placed. So it's going to conform to whatever geometric properties are in place in your design. So the same intersection you see in the image here may look totally different when it's placed on your design with curved roadway in super elevation. In short, this technology is powerful. From a technical perspective, you can think of a civil cell as a hierarchical placement of elements based off a reference element or elements. By definition, you need to know a reference element is a base element used in the cell that will represent an element that we expect to see in the design. An example would be a road center line or edge of pavement. In short, though, for a civil cell to work, all the elements and components within that civil cell need to be fully constrained back to the reference element. You can also think of a reference element as a parent element and all the other subsequent elements as children. Use cases for civil cells would include traffic management, junctions, driveways, medians, ponds, ramps, parking bays, roundabouts, and more. So civil cells, being as powerful as they are limited only by your mind and what you want them to do. Being that Open Roads technology has been out there for over a year now, we've been working with various users and organizations, and we've come across users and organizations facing many, many challenges trying to work with this technology. Some of the challenges I want to list here, beginning with examples. The example cells that we've given in the workspace were meant just for that. They were examples. They don't match the organization standards. So unless you're have adopted the example workspace as your organization standard, you're going to find the features and templates and components and level structure and so forth just simply doesn't match what you're working with today. So the user has to go out and change those standards to match if they want to use those cells. A lot of times, once modifying these cells, that cell becomes invalid because there is a specific process that needs to be adhered to when making those changes. Another problem or challenge may be that the example cell doesn't match your design needs. So the basic T or the T with an island and so forth may be good, but you're working with a C-type curb and not a mountable curb, or you need dual islands, not just one island, or dual turn lanes, and so on and so forth. So it just doesn't match, and it needs to be either modified or a new cell created. So once somebody begins modifying or working on a new cell, they create a civil cell that doesn't work or works in part. Maybe it works in some situations, but not in others. In some designs, but on the next design it doesn't. Or maybe within even the same design, where on one intersection a cell place is great and on the next one it just fails in some way. Why would that be? We've seen where users are unable to create a civil cell that works anywhere, except within the test that they presented it as they're working on it. Other users simply don't have time to create the civil cells they need. They just need to get the project completed and opt to simply do the design using previous methods that they used in maybe earlier versions of our software or other companies' software. So why? People find themselves, or we see people asking, why doesn't this technology work for me? Is it because I'm a new user and I just don't understand all the aspects of the software yet? Or maybe I've taken all the training there is to take, but they just don't have a training on a civil cell for a roundabout, so it's not working for me. What do you mean I need to understand all the geometric rules? What are all the geometric rules? Where can I find them? How does it work? Or maybe the situation I'm trying to create the cell for is a 20-leg roundabout intersection. It's just too complex. But folks, I've been working with people for the past 2 years now with this technology prior to the release of the first software and up till just the other day. And the main reason why civil cells fail is horizontal geometry. In fact, 90% of all civil cells that fail due to improperly constrained horizontal elements. Included in that would be the horizontal element placement failure due to a lack of understanding of reference element directional control. Now, folks, the issues that I point out are not easy issues. I would not expect a beginner working with civil cells, or even someone working for the past several weeks with civil cells, to fully understand these issues. The horizontal geometry that we've included in our product is very powerful. Because it's so powerful, the user may understand an array of rules and snaps and placement options and so forth, but there's probably, as much as they know, there may be that much more that they just haven't touched on yet. The other issue regarding positional or directional referencing within elements is a difficult concept for someone to understand that's new to the software, and only with working with the cells for extended period of time will they come to fully understand this and fully see when it's necessary to control. So don't lose heart, there's hope. And what we've done is we've introduced a core civil cell. So because the majority of failures occur on horizontal geometry, it's usually occurring early on in the cell construction. So we've simplified the construction of the cells. We've provided An example that contains the core geometric elements and contain terrains, rather, the core geometric elements and terrains needed to generate the cell. Once these are given to the users, we found that the users are able to greatly expand on these to conform to different situations that they run into with a very high success rate. These core civil cells are easily expandable to different situations. They're also easy to modify to organization standards because they only contain the core elements. The user doesn't have to fight through modifying templates and components and underlying elements and so on and so forth. They're simply modifying the base elements of the cell to their standards and the dimensions, regardless whether they're working in metric, imperial units, survey feet, whatever it may be. And because we're providing a core, we're giving you the ability to develop your own flexible workflow within the cell environment. So you can opt to copy the libraries, modify the dimensions, the features, put on your own components and templates, adding them that meet your standards, or you could place multiple copies of the core and expand each one of the core cells to meet different situations and scenarios that you might encounter in your designs. Or last, you could develop or use the core cells as is, placing them into the design where then they're modified and placed over and over. It's up to you, the user, how you want to work with these cells. Finally, we're going to give you an entire series of instructions. So a powerful tool without instructions is very limited in its usefulness. What we intend to do is show you how to modify the cells, how to work with the cells before placing them, and then the different ways cells can be worked with, and once placed, how to make modifications. We're also intending on showing you common issues you may face when placing the cells and how to tackle those issues. The cell libraries we're providing with Select Series 4 include an intersection library, which includes multiple entry and exit ramps, basic T arrays, roundabouts, and miscellaneous T cells. Also a library providing for medians, complex medians, basic medians, turn lane medians, and crossovers at medians designs. How and where you're going to get these cells? Well, if you're on Select and you download Select Series 4 release that's upcoming, the library will be contained in the example workspace. It will work with Select Series 3. So you can grab it from a friend or a colleague who's downloaded the latest and greatest build, but you're still on SS3, and simply use it as you would any other cell library. You can also email me, mike.barcassi@bentley.com, for the latest versions. As I work with these cells, I find situations where they need to be improved. And as I'm the builder of the cells, I'll make the improvements so that they'll work better for you. My goal is to make you as successful as you can be with these civil cells. I would like nothing more than to see what you, the user, come up with and how you can modify and eventually create and work on your own. So you're going to want to follow up with the next video / demonstration on how to modify a core civil cell. It's very important that you follow along in the series. I'll try to keep things short and to the point. I know I like to talk. And you can follow the MBuilds channel on YouTube for all future videos. I look forward to working with each and every one of you. I look forward to fielding your questions that you might have. Have patience as I do get inundated at times, and look forward to seeing you in the next video. Thank you.